Good afternoon, everybody, and welcome to another Geo-Institute live stream. You are here, you are present for the second preview of the Geo-Structures conference, which we will be dropping on the geotech world the week before Thanksgiving in November. My name is Brad Keeler. I'm the director of the Geo-Institute, and we are thrilled to have you with us today as we have a presentation, another killer local case history to get you fired up for Geo-Structures on the Mount Washington landslide remediation. Couple of notes first. If you don't know anything about the Geo-Institute, I always wonder how people end up watching us if they don't, but just in case, after you watch this presentation today, you can and should head over to geoinstitute.org. There you will find out all sorts of things about us, including that we're a technical society with about 12,000 members, most of whom are geotechnical engineers and or geologists, and that we are part of the American Society of Civil Engineers. And if you like what you see today, Brian, nod if they're going to like what they're going to see today.
Absolutely.
That's so much confidence. You should click like, subscribe, and get notifications, and we will let you know every time we post something to the YouTube channel. The city of Pittsburgh and its inhabitants are very excited that we are coming their way, and so today, we have two of those individuals who just happen to be geotechnical engineers here to introduce our presenter, Brian Heinzl. It is Laura Cisak and Taylor Dacanal. Taylor, Laura, thank you guys for doing this. Do the intro and let's have some fun.
Will do. Thank you, Brad. Thank you, Brian, for presenting today. As Brad mentioned, my name's Laura Cisak. I am this year's GI chair for the Pittsburgh section, and we are super excited to have you all come to Pittsburgh November 17th to the 20th. The day the conference kicks off, November 17th, there are amazing short courses planned, so a good way to get your PDH hours completed. The conference is jam-packed with technical information. We're going to have events so you could socialize with your industry peers. And I do want to give a shout out to the local GI as well as our local geotechnical engineering community throughout Pittsburgh. I know many people are participating in panels. They have stepped in as moderators and have done paper reviews. So really appreciate that. And really looking forward to Brian's presentation today. We talked about going live on site today, but we figured since this is a live stream, that might be a logistical nightmare. But if you do plan to come to Pittsburgh for the conference, I encourage you to go up to Mount Washington. The views are phenomenal, and you may stumble upon one of Brian's projects. So with that, I will give it to Taylor to introduce herself as well as Brian. Thank you.
Thank you, Laura. Hi, as Laura said, my name is Taylor Dacanal. I work for a geotechnical consultant firm here in Pittsburgh. I'm currently on the board as a member at large of the Geo-Institute board, but I was also a past chair. Now I'm watching Laura run it, and she's doing great. And everything she's doing and our board is doing for the conference is going to be awesome. So if you're around, you should definitely stop by, say hi to us, say hi to Brian. So with that, let's introduce Brian and get the presentation started. So Brian Heinzl is a geotechnical project manager for the Gannett Fleming in Pittsburgh, in the Pittsburgh, Pennsylvania office. He's a graduate of the University of Pittsburgh, earning a Bachelor's of Science degree in civil engineering in 1989. He holds a professional engineering license in the Commonwealth of Pennsylvania. He has spent much of his 30-year professional career performing geotechnical investigations and designs for various clients throughout Western Pennsylvania. Over the last decade, his efforts have been focused on design and construction of landslide repairs throughout the Pittsburgh area, assisting DOTs and other public agencies and contractors with maintenance and improvement of the existing transportation infrastructure. He has collaborated on several technical papers and presentations resulting from the landslide stabilization experience. He is an active member of the ASCE and ESWP. He currently serves on the ASCE Section Board of Directors as the chairperson for Educational Outreach Committee, and he is a past chair of the ASCE Pittsburgh Section Geo-Institute and a current member at large. So with that, Brian, go ahead.
Thanks, Taylor. Thanks, Brad and Laura. Hey, I'm going to share my screen here and we'll get started. I'm going to share with you today a couple of projects that we're doing for the city of Pittsburgh on Mount Washington. Just verify that that's up on the screen there, Laura, for me.
Looks good.
And I can get going. Oh, thanks, Brad. Okay, so this is a project, or there are several projects here, 3 different sites that I'm going to go over today that we have with the city. We'll do a little introduction, geologic overview, some of the project background and investigation, and design and construction. So before we start into the specific projects, the project team here is like Gannett Fleming is working for the city of Pittsburgh, and the city obtained a grant through FEMA, and it's being facilitated by the Pennsylvania Emergency Management Association, and we meet with them monthly on progress and to bring these 3 projects that I'm going to talk about to completion. I do believe we started on these in 2021. They should all finish by the end of this year. And before we get into the specific projects, I just wanted to kind of go over some of the geologic background here of the Pittsburgh. You see the golden triangle right there in front of you. These 3 sites are up on Mount Washington, which is a steep valley slope that you can see. This map here was generated by the Allegheny County, and it basically shows you that all of these slopes around Mount Washington are susceptible to landslides and rock falls. So, and this is some of the common geotechnical constraints we face in Western Pennsylvania. For those of you who are not familiar, we have these deeply incised valleys here that were downcut through geologic time, and with the steep slopes and the stratigraphy that we have competent sandstones that are interbedded with weaker clay stones and shales and limestone units, and we also have coal seams within the mountains here that the less resistant units tend to degrade faster than the resistant units, causing rock falls and toppling, but they also cause these colluvial deposits at the bases of the valley or on intermediate slopes here where you have the less resistant units lying on top of the more resistant units. So, and the colluvium is just the downslope accumulation of the weaker material. It tends to have low strength properties and continues to creep, especially when disturbed by construction or other man-made activities, and is very sensitive to precipitation. Oh, going the wrong way. Hold on. There we go. Go the other way. And this is just kind of a geologic section of Allegheny County here. We have outlined in blue some of the prevalent marker beds, being the Pittsburgh coal, the Ames limestone, and the Upper Freeport coal. And also shaded in red here are our problematic red bed claystone seams, being the Shenley red beds, Pittsburgh red beds, etc. Some other red bed units in there. So that kind of that's the setting of this project. Here I think our project basically Mount Washington. I do believe the Pittsburgh coal was pretty much near the top of Mount Washington, which was named Coal Hill back in the industrial age, and is now Mount Washington, because that's probably not very aesthetic to call it Coal Hill anymore. except for us engineers. So we'll go on to the project background here. Like I said, we have 3 sites that the city obtained a grant for through PEMA and FEMA. This is the Greenleaf Street site, is a catastrophic landslide area. The Reese Street site's a smaller slide, but it's got some important properties around it. And then over here above the Liberty Tunnel, William Street, it has several instabilities, landslides, and other rockfall issues that we were addressing. So our objectives here were to protect the roadway properties and also consider the city has this Emerald View Park, which is basically the green space all around Mount Washington that's undeveloped land. And they have a series of trails through there that they maintain. So this is the Reese Street site. If you can see it here, this is the top of Mount Washington. There's a radio tower here on the top of this building, which you can't see in this view, but it's very important to the Pittsburgh area. And there's a landslide occurred behind the structure. This retaining wall here supports the structure, which you can see in this view right here. So this material moved down slope, and you have some steep outcrops encroaching on the Emerald View Trail, runs below the site across the middle of the hillside. So the potential for rockfall and slide debris to impact the trail and other infrastructure downslope to the railroad and the major state route here at the base of Mount Washington. So our objective was to construct something to mitigate this slide. This is kind of the typical section that we came up with. Our treatment was here. This is the slide area below the wall. And what we came up with is a structural barrier of closely spaced caissons to restrain the upper slope movements above this steep rock outcrop. And this is just the limited disturbance for our project site. Stayed up out of the park for the most part, and we were up against this high-rise building next to us, and this is the radio tower just above us. So it was very, very tight site. And it's called Reese Street. Reese Street is a city street that runs out dead ends at the site, but you can't access the site here and I'll show you in a minute. I think there's other better photos. The local residents have appurtenances built around their structures there. And this is just to share a couple of the site investigation challenges here. You can see that these gentlemen are trying to collect subsurface soil samples for us there with this drill rig that they basically carried over the slope and built on site to take the samples, and this is them right above this, perched rock outcrop below us. So very challenging terrain. And this is our typical section here, and this is the depiction of the site with the trail. This is where we wanted to construct the caissons through the slide, and this is it in cross section. And through our subsurface investigation here in some of these borings, we did find this is the Pittsburgh coal horizon that I mentioned. It is coal and collapse mine interval here that we had to address prior to constructing the caissons. And this is just a, construction plan of the site showing we did some regrading here. Here's the existing wall with the failure area, caissons running across the slope, and we put intermediate HDPE pipes between the caissons. This allows the drainage to continue to flow over the slope, so we're not blocking, resisting any hydrostatic pressures here. And these were the rock outcrop areas that we had some scaling done as part of the project. So, and I think this is just a schematic view or elevation view of the treatment. This is Pittsburgh coal. We had mine grouting injected probably it looks like every other caisson. Here we're just building pillars to hold up the mine roof, and then come up and construct the caissons, and then put in these intermediate HDPEs. We had a little bit of reveal here, and I'll show you that. And this is we did basically some as directed rock slope scaling. This is kind of what we had to come up with a way to convey to the contractor which rocks to take off the slope. So we basically had a drone go out there and fly it. We just did an oblique aerial here and identified specifically what rock materials we needed removed from the slope that were considered potentially dangerous and may fall. And then here again, this is a construction plan showing the access re-street here. All these appurtenances were to remain. So we basically came up through the alley with all the equipment and down on this little postage stamp of a site. And you'll get a better perspective of that with some of the construction photos. Construction bids were open in October of 2023. Awarded the Conroe Paliotta Contracting, a local contractor, for about $1 million. And the work right now on this site is substantially complete. And I'll walk through a couple of the construction photos. This is the tower, the building, the site access. So they actually had to put in some temporary shoring to get down here on this plateau for construction of the closely spaced caissons, and did a little bit of rappelling, I think, down here later on to remove some of the rock blocks. And you'll see this is just another picture of the contractor performing the mine grouting. These are all the mine grout ports here, but they have come down here, and I do believe that it's finished at this point, or I think they just finished drilling at that point. And then this is kind of I like this picture a lot. You can see that they have like basically equipment stacked on top of each other, and like I said, on this little postage stamp of a site, this is all the caissons installed. And I believe right now they're excavating to install these HDPEs behind them to create this little bit of, I think it was a 5-foot reveal we ended up with behind here, and then some regrading filled this all in back up here later when they removed all the temporary measures. And then this is basically the completed site. This was done, I do believe, by, I think this is April or May. So this one was substantially complete. One of the things that the city wanted us to do here, you can see all the caissons here. We had added pigmented concrete to the top of each pour, so this would kind of blend in and you wouldn't see, what everybody calls it, the ugly gray concrete wall sticking up in the middle of the hill. So that was very, very important to the city there, especially because it's part of their Emerald View Park. So this is the Green Street site. In 2018, there was a catastrophic failure basically from the top of Mount Washington down onto Main Street in the West End. And this is hundreds of feet, thousands of cubic yards of material that were displaced, and took out a lot of the Emerald View Park Trail. Plus, it actually took out a home down here, and closed Greenleaf Street and part of I think this is 19 and 51 down here in the West End. So this is here's an aerial view of the catastrophic failure, and this is the 2018 was basically one of the years in Pittsburgh that we had a record amount of rainfall, triggered a lot of landslides. And those of us that are local geotechnical engineers were very busy that spring trying to repair infrastructure, kind of similar to, but not nearly as bad or widespread as what's going on in Asheville, North Carolina right now, luckily. So this is the house that was removed. It was here, so you can see this was the trail came up across the site here at the headscarp of the slide, And this is part of an ancient landslide area here that was also reactivated because of all the moisture and some other influences that caused this failure. So we came up with a couple of different designs, and because of the depth of the colluvium here at the base, we came up with some deep soil mixing lines, which were these represented by these two lines of material, and this a rock buttress on top of that, and then up here a separate remediation for the trail. Basically, we have a combination of micropiles, geogrids, and soil nails because of some of the site constraints here. And this is an overview that's showing this is the ancient slide area that was mapped by some of our desktop study. This was the active slide from 2018. So the city primarily wanted to arrest this. There was the cleanup that was done here in 2018 was to open the road and get the site back to a usable condition and reopen Greenleaf Street, but there was never really an investigation or a design to assure that this thing was going to have the proper slope stability for long-term future conditions. So that's what our responsibility was, to come in here and make sure that these were, built back to a factor of safety of 1.3 to 1.5, something in that range, whatever we could obtain specifically. So this is a cross-section of the lower portion. So we came in here with some deep soil mixing panels. I believe the widths changed. I think their lower one was 15 feet wide, and I want to say there were 10-foot spacing, 4-foot thick panels at a 10-foot spacing. And this, the upper one, I believe, had some different shapes and sizes, 30 feet by 4 and 15 by 4. I think when you get out into the ancient landslide area. So these are kind of the bunch of borings that we had. We had a bunch of borings that we record drawings from PennDOT's West End improvement project, or some of these solid borings. They have pretty significant retaining wall down here below Greenleaf Street. And these were some additional borings that Gannett Fleming had done, and the city had done some test pits up here in preliminary design. So we kind of took all that information and looked at what do we think's going on here. And this is a I think it's this section AA. If I go back a second, there's 2 sections across the slope, AA and BB, and you can see just based upon what this looks like, we have a 35-foot depth of colluvium here at the bottom, and then it shallows up to maybe 20 feet up here, and very, very variable conditions here. And we came up with a minimum bottom of mix zone. These were our targets on AA, and then you have the same thing on BB, which kind of the opposite direction of the boring. So this wasn't something that we could come up with a single specific section or depth. And that's kind of one of the reasons why we went with deep soil mixing, because it's a little versatile. You can have one panel a lot deeper than the other, but we did need to get the 40 plus feet with these theoretically. And this is some of the segments. Like I said, we had 3 different treatment segments here. This is through the active slide. This is Greenleaf Street. We did some roadway reconstruction there. And this is another line of columns through the ancient landslide area. So we actually had 2 there. And then the rock buttress up above here. Now what we did is we kind of stopped this rock buttress at this location, which kind of worked out. There's some wooded area up here that seems to be stable from this tree line. But we have a lot of power lines running across this site, so we can only build our rock buttress up so high and still get under the power lines without having to interrupt any of their facilities. And this is the trail area. So we have, again, this was pretty much obliterated by the slide, and there's a small walking path here. So what we're rehabilitating this with soil nails on the slope to create our path, and then build the path up with geogrids and reinforce it with some vertical micropals down into competent material with residual soils and bedrock. And this cross section shows, here's our residuum. The bedrock is not too deep. These are 10-foot sections, so we were able to do something a little bit smaller up here, but we had to get through the micropals in the front here into the residuum. So this area here is untreated. It could still creep, but it won't affect the path for the Emerald View Trail. This is a plan of that. And the soil nails are up in here. We couldn't go across property boundaries. That's, you see all this boundary here, and this is the city. This is a paper street that the city owns, so they could come down through this area as contractor access, install this line of micropals. I guess the sequence would be cut this down, put the soil nails in, put the micropals in, and come back through with the geogrid reinforcement to recreate the path. I do believe this is 200 to 300 feet across here total. So again, this bids were open here the end of last year. Carmen Pagliato was a successful bidder on this one as well. The contract price is $4.4 million. The work is ongoing now, and we estimate completion in December. This is the rig here they used to create the deep soil mixing. Actually, they did a VE. They didn't mix soil. They actually came in and did partial displacement concrete piles overlapping, creating the same panel, which saved us some time for testing and sampling of test panels, because we knew what the concrete piles consisted of. So the contractor had his engineer go back and just verify the stability worked out with the deep partial displacement piles. So we continued with that. They're working on that right now. This is just this is the upper bench, I do believe, some of the colluvial area, creating a working platform for this machine to travel back and forth, creating the panels. And this is just another view from below. This is Greenleaf Street here. The upper panel here is complete. They're working on the lower row now. And you can see this area here was the partially repaired active slide from 2018. The city installed some drainage here and did a bunch of earthwork just to remove the slide debris. So we're going to do some of the improvements on that. And I don't know if you can see the utility lines coming up through here, but they go right over the rig there. This is just another view of the bench being, I do believe all the panels are in, and this is the finished grading of the lower bench. As you can see down into the west end and the west end bridge in the background there. So we're going to you'll see a rock buttress up across here. The objective here is back here is we will build a rock buttress here, but we'll also, I think we're going to choke it with granular embankment and plant grass and some trees on it, again, because to facilitate the greenery and create the park-like atmosphere for the city. This is the upper part, which the contractor is just getting started with. This is the trail now coming across here. This is the headscarp of the old active slide, and they're creating a bench here that we're going to do some test soil nails here in the next week or so. Now we'll run over to William Street here real quick. This area is the slope above the Liberty Tunnel that goes into the South Hills of Pittsburgh. This is the mouth of the Liberty Tunnel here going out onto the Liberty Bridge. And this is Arlington Avenue that goes into the South Hills. And this is William Street that traverses up to Bailey, up to the top of Mount Washington. And these are several areas of movement that the city had identified for this project. I think we'll end up calling this area 1. We constructed a wall here. This is area 4. There's a couple of homes up in here that there's a tight access driveway. This area here was repaired again by the city before Gannett Fleming got on board. This is basically a rock buttress. They had the landslide here came down and took out one of these houses. They had to condemn the house and come in here and rebuild this under emergency conditions. And then we're able to come up again with the FEMA grant to help them and us design other remediations for the other slide areas that you see here. And this is a view of the street. The street was a narrow one. It was one lane. I do believe it was one lane down the hill here. And this is it was closed off. It's been closed since 2019, since the activity there. And I do believe 2018 this area was closed. I think other parts of it were closed. It was open to here, but then of course the other slide that I showed you in 2019, the lower portion was closed. So this is just a view of all the mud and debris that washed down on the McCardle roadway below. This is the headscarp. This is the tow area along this hillside. And I'll move forward here. There's a lot to cover on this site, which we won't get into very much of it here due to time, and we're still working on it, but we can come back and recapture this at some other later date. This is we had to build a temporary road here to cross because these folks were cut off once we start our construction for our repairs here. We were cleaning up that catchment ditch that you saw. We're going to build a anchored soldier pile wall on this corner. And in addition to remediating the slide, we're also reconfiguring this turn in order to facilitate emergency vehicles coming around here. As on this other picture here, you can see a fire truck to service these vehicles down here that would have to come up here and back down the street. And the city wanted to improve this, so we made this a bigger radius so you can actually turn around this bend while we were doing our slide repairs. And based upon some options that we looked at here, we determined with the city that this portion of William Street would remain closed to vehicles, but we would reopen it as a shared use path for pedestrians and bicyclists that would allow people to still have access to Arlington Avenue bus lines and bike Pittsburgh and such, but no longer vehicular traffic. So we're able to narrow the section up a little bit. And this is just a view of cleaning off some of the slide debris. We're cleaned out the ditch here that actually worked pretty well. We had a limited closure on P.J. McCardle roadway. It's a very active thoroughfare from Liberty Bridge downtown to Mount Washington for daily commuters. So we're able to shut it down over a weekend to do this clean out and remove a lot of the slide debris, which was very successful. This is a depiction of the anchored wall. The new Cola Street turn, William Street is up here. So you can see we moved Cola Street out, made it a little wider on that reveal, and this is the anchored wall below it. Here's a plan view of the similar thing. This is again, I just wanted to highlight the intersection improvements. This was the existing hairpin turn. now we have a larger radius to allow emergency vehicles to make that turn and service the residents. This is the trail, converted trail. In order to restore this area, we designed some soil nails to come in here, and we have permeable pavement that's going to go in here, and this is a small rock buttress. Some other areas here. This is a plan view. This is the area of the soil nails, the drainage, the anchored wall, and this is going to be the trail. I believe we had 300 nails maybe through this area, and this area here. We have rock lining going in. I don't have a good picture of it. I just have a general schematic here. We have some mine drainage or surface drainage seeps coming out of the slope here that basically remain saturated throughout the year. So we're going to stabilize the surface to try to keep the soil from creeping and manage the water and get it into a controlled environment. That's this depiction here with this Gabion mattress. And this will be the William Street Trail coming around, and we'll have a little impoundment here and get it into the drainage system that was all designed and upgraded as part of the project. And so, like I said, several other smaller retaining walls were designed and constructed here. This is the area 4 adjacent to the driveway, which I don't see in this view, but it's right here. So they had to make sure that they had access for the residents while they were constructing this wall on this narrow roadway corridor. And this is the lower wall. Again, there's another resident here. This is the new wall below this narrow street on this very steep hillside adjacent to Arlington Avenue. And these are some of the ecological stabilizing elements to go with the park theme. We had a bunch of trees planted to screen the walls and live stakes planted in the rock lining to be able to return the slopes into a green park-like setting. And this is the construction here, just real quick. Allison Park Contractors was awarded this contract in February. Overall, the project cost was about $5 million. The work is ongoing, and we expect to finish by the end of December, maybe early January. This is just some of the photos of this. Is the Cola Street turn here, the new retaining wall that they have all the soldier pals in, creating some temporary access to start putting in anchors. And this is just to show that the tight quarters. This is the resident driveway here that they're trying to leave open. So this machine had to come in here and drill these beams in daily and move and put up some protection so the folks could get in and out when their shifts were over. But everybody pretty much cooperated. We didn't have very much trouble. The two lower walls are in and complete. This is a view of the new William Street mixed-use trail. The soil nails with Teco mesh and the plates that actually went in pretty well according to plan. The contractor did a good job here. And this will all be planted, and we'll all have greenery on it. This part of the trail will get a handrail for bicycles and pedestrians, and that's not the handrail. That's a temporary railing above that area 4 wall that's across from the driveway. That's just kind of a finished look for the wall. And again, the concrete panels were all dyed with I think it's walnut to try to blend in with the surroundings, so we didn't have the big gray wall sticking out of the hill. And this is a view of the lower wall adjacent to Arlington Avenue down here. That was to rest this slide area along the narrow street at the bottom. And just if if you want some more information about what's going on out here, I invite you all to look up this Engage Pittsburgh, pittsburghpa.gov, and go to the Mount Washington Landslide Remediation. There's more information and background on this website that the city maintains. And that's all I have. So if anybody has any questions, I'll be happy to entertain them. Throw it back to you, Taylor and Laura.
Great presentation, Brian. Really informative. We really appreciate it. Your last project, you mentioned the Liberty Tunnels. And for those of us who are local to Pittsburgh, the Liberty Tunnels have officially been open for 100 years. So I know that the ASCE Pittsburgh section is trying to maybe have a few events around that or commemorate the tunnels in some sort of way. So if you're in Pittsburgh and want to keep up on that, keep an eye out for the upcoming ASCE events around the tunnels opening.
All right.
Yeah. Go ahead, Taylor.
Start us off with some questions. Are you ready, Brian?
I'm ready. Have at it. What did I leave out?
I guess the construction is super interesting on all of these locations. So what would you say is the biggest construction challenge that you have? Maybe per site or just in general, but whatever you...
I think in general, what we had to consider is mostly the tight constraints, staying within the city's boundaries, right of way, right, per se, the street right of way or temporary access that we acquired, or to try to minimize any impacts outside of that and still get the equipment in there. And the best depiction of that was on the Reese Street site. You saw 3 different pieces of equipment stacked on top of each other trying to build those caissons in there, which that says that the contractor did a great job of coming up with the access that he needed to do that. And on William Street too, you can see the streets were so narrow, but we still had to maintain access to the residents while they were building it. And they were able to meet that challenge successfully.
I feel like some Pittsburgh streets, even without construction, are too narrow. So I can't imagine getting stuff up and down.
Right. You're lucky to get the snowplow up and down there, right?
Yeah. Yeah.
Brian, in terms of the construction, were any other options considered, and what were the drivers for the selections of construction? Was it time, cost?
I don't think time. I mean, the project does have a time limit for the grant. There is a certain amount of time that the project has to be completed in. But I don't know that that was necessarily a driver early on in the design. It was more or less what was feasible. What would we be able to do and not have to take a bunch of property from a bunch of the surrounding residents and access. So and cost. I mean, there was. For example, I think on the Greenleaf Street site at the bottom, we started out with 3 options. I think the deep soil mixing, which we ended up with, we had thought, well, maybe we could regrade it and just put some soil nails in to stabilize the bottom portion of that site. Or maybe we could come across there with a similar treatment that we did up at Reese Street. It's come across with some caissons. But subsequent to our investigation and some of this, we had a little bit of background on because we were around as part of the 2018 cleanup that the state did, and looking at it back then, that we knew that a lot of the colluvium deposits, some places it was very deep, some places it wasn't very deep. And I think I said that during the presentation. That was allowed us to adjust during construction, and actually the contractor went out there and did some pilot holes across that bench to be able to come up with a material delivery schedule, right? He knew which places that was deeper, going to take more concrete, because once they started a panel, you had to finish the whole panel because it had to all go in the wet. So he had to. So I mean, some days they were out there for 12 hours doing a panel, and some days it was only 6 or 8 to complete the smaller ones. But it was all dependent on what the depth was. So that lent itself to a little bit more flexibility. Caissons, again, there's slender, tall elements. If you're 40 feet of colluvium, there'd have to be monsters. They'd basically have to be all steel, just because of all the bending. So that wasn't very cost effective. And what was the soil nails? Again, we said some of the colluvium was 30 to 40 feet to something competent. Maybe it wasn't all colluvium, some of it was residual, but you have these slender nails in there going 40 feet through colluvial mass. It's just not, you wouldn't get the factor of safety that you're looking for.
So we have some questions coming in now from some of the viewers. So I think the first one's interesting because I think as geotechnical engineers in Pittsburgh, I don't want to say take mine void remediation for granted, but it's just something that we're used to seeing on projects. So this question is about the mine void beneath Reese Street. Was it an open space that workers were sent into, or was it filled or collapsed? And how did you get the grout where it needed to go? So interesting for people who haven't dealt with mine void remediation much.
Yeah, good question. I guess I didn't go into that too deep, but Mount Washington, like I said, was called Coal Hill. There was commercial mining, but there was also with mom and pop local residents excavating coal at the outcrops to, heat their homes or sell themselves. So depending on what type of mine is, or if this was a map, this area wasn't mapped as a mine, but we knew the coal was under there. So we did our exploratory drilling, like I showed you, and we did find some collapse, but don't know that it was commercial or how extensive it was into the hillside. We didn't really explore that. Well, I can't say that. We did, based upon our desktop study, and some of our project team was involved with the other walls that were built surrounding that structure. They had done an extensive mine grouting program under the building. So we kind of knew what we were up against there. So as far as were there people in there? Maybe. I mean, the Pittsburgh seam is 10 feet. It's 10 feet thick. So if you mine it out, sure, you can drive through it, right? Mining vehicles, a lot of Pittsburgh is undermined with a 10-foot thick seam taken out. So how do we grout it? And if you recall some of the illustrations I had, you saw like the conical shaped grout backfill. That was basically concrete. So we pour concrete into the mine, and it basically, if you pour it in there unimpeded, it'll basically form a shape like at a 1.5 to 1 or a little bit steeper. So you're forming new pillars to hold up the mine roof, and you're reducing the span, and so the vertical stress on the overburdened rock, you're reducing the stress. Therefore, you remediate any collapse. So I think that was hopefully that answers the question.
Sounded good. Brian, remind me, what was the first project name?
Reese Street?
Reese Street, yeah. What was the philosophy behind the caisson design, specifically in terms of the factor of safety?
What I try to do, and through my experience in doing these landslide remediations, is basically try to, if you can improve the soil, right, or remove the soil or reinforce the soil. So this ended up being, you couldn't really do A or B, so we ended up reinforcing it with the caissons, so that would cut off a slide, but when we space them, you allow arching in between. We're not trying to create a grade separation structure, right? We're just trying to reinforce the soil mass that's there. And so we can space them out so much to allow arching, to allow the caissons to attract the load. But we also put in those HDPEs, filled them full of gravel. That way it lets any groundwater that accumulates still proceed through the geotechnical treatment that we install.
Were any of those caissons tangential to each other, or was it just the HDPE pipe?
I think that I can't remember what the spacing was. There were 42-inch at 6-foot spacing, I do believe. So there was about, there might have been 1.5 feet or so between them. And then the HDPEs were augered in between, so they basically touched the back of 2 of them.
Got it.
And not necessarily as lagging, but they're there to allow some of the soil that's in front of the caisson to continue to ravel without worried about any of the exposed soil. Even though there is arching, if it's exposed, you'll get erosion between the caisson elements.
Another good question that came up is, since we talked about the difficulties of getting to the sites, did you consider any geophysical investigation to get to areas that you couldn't necessarily get a drill rig, to determine depth to bedrock, or any other instrumentation that you've used on these projects?
Not on these projects specifically. There was some background information. Like I said, there was some preliminary engineering that was already done that kind of was, we were able to just supplement that with a couple of borings. And like I showed you, some of the drilling that we had to do was basically, build the rig on the slope with specialty drilling contractors. But the conventional SPT sampling to rock was, and coring of bedrock, of course, was considered adequate. We did not entertain any geophysics on this project, but we have, of course, looking for voids, or a lot of times we use it for looking for voids. And if we have time, we have some other sites where we have a bunch of colluvium, we know it's creeping, so we can instrument it. To instrument it and come up with any effective conclusions, you need time, right? You need time for be able to read inclinometers, right? Over at least, I would say at least a full season. So that way you get the full fluctuation of groundwater, at least for one season, ideally more than that. So you have a full understanding of the conditions.
Are they doing that anywhere on Mount Washington, do you know, for any future projects, or do they have any future areas that they're looking at of concern?
They are remediating some other slides that we're not involved with, that they put out for, other consultants to bid on. So I'm not really aware of any specific instrumentation that the city has out there, but they possibly could.
Particularly the Greenleaf slide, we have a question regarding what considerations were taken to treat the apparent seeps that could be coming from the mines above the sites?
Good question. I showed in one of those slides, the city had put in some rock lining on the slope, and that seems to be accumulating a lot of the drainage, whether it's coming seepage out of the slopes and the bedrock or from the Pittsburgh coal seam above. It is finding this ditch, and basically we extended that ditch through our treatment. Again, we spaced the deep soil mix panels to allow this drainage gallery to cut through the middle of it. Like I said, they're 4 foot. I think they're 4 foot thick panels at 9 or 10 foot center to center. So that allows like a 5 foot trench, and we'll have that seepage or surface water collected at Greenleaf Street, and basically collects at Greenleaf Street into the existing system that's that's out there that goes out into Sawmill Run.
Thank you. The first stabilization is a popular one because we have some more questions on that. Can you comment on the methodology used to determine the landslide load that's applied to the pile for the soil structure interaction analysis?
Wow. That's a deep one.
Yeah. I don't know. If you can just give us a quick summary, I guess.
I'm trying to think of, well, so how we modeled that was basically we took the panels themselves, and if you look into the I think it's FHWA guidance on deep soil mixing, you can make these panels. You look at them as stiffening elements. So you want to do a certain amount of stiffening. I think we ended up with 40%. It's a 40% aggregate looking at into your stability model. And once you have enough of your material across the site stabilized, 40%, 50%, whatever the factor of safety comes up with, then you have to check each panel itself for bearing, sliding, and overturning. And like I said, I think the procedures are outlined in FHWA manuals.
Yeah,
we kind of followed that for guidance, and we did have, which we've done in the past on these test panels that you put in for different level or different amounts of water and cement mixing. So I think we went with like 20, 25, and 30 on another project to try to decide what is the ideal mix that gives you the compressive strength that you're looking for in the panel element stiffening. So we were able to skip that on this because of the VE that proposed by the contractor. He basically used I think it was 2,000 PSI concrete.
Thank you.
Yeah, I think, Brad, how are we looking on questions?
I think we're done.
We grilled Brian enough.
Yeah, hey, when you're there for Geo-Structures, you can see William Street is right above the Liberty Tunnel. I know, talking to some of the guys from the county, they look at what we're doing up there every day on the way home. And every once in a while I get a phone call.
So that was
good.
That was perfect. So Taylor, Laura, thank you guys for running the grilling here. And Brian, thanks for a great presentation. I really love doing the local case histories before conferences because it is kind of cool, right? For people coming in from all over the country and all over the world in some cases, this is their opportunity to really get a flavor of what geotech is like in a place they're not super familiar with. So I think Taylor called it out with the mine voids. That's a perfect example. People in Southern California are not dealing with that, for example. So that was really cool. That was a great presentation. For our viewers, thanks for being with us today. Thanks to everybody who asked questions, but thanks to everybody who just hung out and didn't even say anything. We still appreciate you being here. One thing I did not point out at the beginning of the interview, if you have this in your mailbox, Geostrata, our magazine, you will want to check it out. It's a great preview issue for the Geo-Structures conference. Everything in here is focused on geostructural engineering. If you already subscribe, if you're a member, you can just go pick up your paper copy and enjoy it that way. If you are not, head over to readgeo.com and you can check out the issue, and we will have extra copies at the conference in case you are interested. We should, of course, tell you that you should go to geostructures.asce.org to get more information about the conference and to register. Prices will go up again after October 23rd, so, we want to make sure you save a little money too, but we still want you there. So do go register. We would love to see you in Pittsburgh. If you liked what you saw today, and You're here at the end, so you probably did. Click like, subscribe, and get notifications. We'll let you know every time we post something to the YouTube channel. Our next live stream will be October 23rd, and it will be another Pittsburgh person as Sebastian Lobo Guerrero gives his Terzaghi Day presentation in Spanish this time, by popular demand. So you'll want to be here for that at 2 p.m. on October 23rd. We're doing that jointly with the Chile Geotechnical Society. And then on October 24th will be our next installment of Books Rock with Praveen Malhotra from Ground Motions Inc., talking about his brand new book that's out on ASCE Press on, you guessed it, ground motion. So you'll want to be here for that. You can register for those for free, of course, and all of our other upcoming live streams at our Eventbrite page. So Brian, thanks again for a fantastic presentation. Laura, Taylor, great job doing the interview. We appreciate it. You can meet all three of these guys at Geo-Structures in Pittsburgh. So maybe you want to do that. Maybe that's your incentive to register. Our producer today, for the very first time, her very first live stream with us is Aurora Flager. We appreciate her hard work. We will see everybody soon with another live stream from the Geo-Institute.